order matters, combinations, order doesn't matter. So here we have 3 toys in a bag, and then we're gonna, what's the different ways that we can line them up? 3 different toys, and we're lining them up. Does order matter or not matter if you're lining them up? It matters because you can see a difference, right? It's like if you put posters on a wall, or you lined up toys, or you put books in a bookshelf, you're ordering them. The moment you put them somewhere and I can see a visible difference, that's permutation, ordering them, right? You're arranging them. So if you ever see the word arrangement, it's a giveaway, it's permutation. So here we have 3 toys. How many would go here? How many possibilities? 3. Then 2. Then why is it not 3, then 3, then 3? Which is, this is right. Why is it not 3, then 3, then 3? If you put 3, then 3, then 3, what are you saying? I hear a lot of like, but I can't bird noise that out, so I have no idea what you're saying. I know the answer, and I want to see if any of you know the answer. I will wait. You're paranoid that you're going to say something wrong. Don't really care. Let's go. I say things wrong all the time. I oopsie. Oh, hello.
Because you have to leave one behind.
You have to leave one behind, which is what most of you know in your heads, but you were too scared to say it. Come on, people. Don't be afraid. It's the same as the books. If you go 3, then 3, then 3, you're never leaving one behind, right? If I have 3 toys, and then in the next blank I have 3 toys, did I ever leave one here to arrange it? No. Then I have 3 toys and 3 toys, right? So it's 3, then 2, then 1, which is 3 factorial because you have to leave a toy behind, which is absolutely correct. Genius child who answered the question. You all might be genius children too, but I'll never know because you don't answer any questions. And then, like, maybe inside you know all the answers, but you just keep them dark, deep depth into your soul. Release them to the world, you know what I mean? Your genius levels. Okay. This is the formula. NCR equals n factorial, n minus r factorial, r factorial. It's on your formula sheet. The difference between this one and the P, if you look at it, this one here looks the exact same as this one, except this one has an r factorial on the bottom. The r factorial gets rid of all the cases where they're actually not different, because order doesn't matter when it's a combination. So you aren't actually organizing anything at all. So here it says, 3 students from a class of 10 are to be chosen to go on a school trip. In general, how many ways can they be selected using the formula above? 3 students going on a trip. Is it order mattering if I have 3 students going on a trip? If I said 3 students going on a trip to blah, 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 and they're all 3 different places, then it's a permutation, yeah? But it's not, so it's a combination. Combinations, you go 10, C, 3. If it was a permutation, we would go 10P3. So if I gave you different places, it would just be a P instead of a C, because order would matter, yeah? All right. With the C, we're going to fill it into our formula. Our formula is NCR, right? So this is N, and this is R. And the catch is R has to be equal to or less than N. So if N is 10, this can be 10 or less, right? You can't have 10 people and choose 14. That makes no sense. So your R has to be equal to or less than N, right? So N is greater than or equal to R. Or you could say R is less than or equal to N. Same. All right. So we go to plug it into the formula. The formula is, so if they ask you to do this algebraically, you'd need to use the formula, right? So you'd go 10 factorial over 10 minus 3 factorial, 3 factorial. I'm just filling N in for N, R in for R. So then we get 10 factorial over 7 factorial, 3 factorial. Type it in. Remember, if you have the TI-83s, you have to use brackets in that denominator. If you have the TI-84s or higher, you should use the fraction button if you have it. yet. And you can do it. So if you have a calculator on your body, which you should have it out and you should be typing in because you're the person who's trusting everyone else's answers. Then it comes to the test and the person puts their hand up and they go, Miss Lepp, where do I find that factorial symbol? And I'll say, I don't know. And then I'll walk away and you'll be really mad at me, but you should know. Like we've used it 977,000 times at that point. So I believe in you. You should know where that button is. Yeah? So I don't deserve the anger, I feel like, when I walk away from not knowing where a factorial is. I usually buck on something back because my soul will feel bad, but I'll walk away knowing what it is. All right. What did you get for an answer? Pardon? 120. This? You guys all started at different cadences, so it's like blah blah blah. That's what it sounded like. All right. That's a small amount, correct? You should get smaller numbers when it. Oh, you're really good at you're annoying me. Just walk up to you. Okay. Okay. So combinations should have smaller numbers, correct? Because order doesn't matter. If order doesn't matter, it's like taking those 3 toys and instead of lining them up, taking the 3 toys and throwing them in a bag, walking away. There's one way to do that, right? If I don't organize those toys in that first question, if I just tossed them in a bag and took off with my 3 toys, my little backpack, I would only have one way. I'd take the toys, I'd toss them in, I'd walk off, right? So there's always less options when it's a combination as opposed to a permutation because you're not arranging them. You're just getting them. Yeah? Okay. There is a button. It's right near the factorial button. So press 10, math, arrow to the left, and instead of number 4, you're going to pick number what? Rhymes with 3. 3. I think I see 3 and then 2 is B, right? And then punch in the number 3 and then hit enter. Voila. Now if it says algebraically and you just punch into your calculator like that, maybe it'll give you 0.5. You just come up with 10C3. Maybe 1 and 3. 1. But you didn't tell me algebra. Get here. Okay? All right. There's also a catch with C's. So P, if we were just sending 3 people to go on a trip, they were going to Medicine Hat, Colorado, and Hawaii. I don't know. I don't think Hawaii. I've never been there. I kind of want to be there, so I think I just honed my own selfish wants into this. If there's 3 different places we're going, then it would be 10P3. Type that in. 10P3. Is it a little bit more? Yeah, it's way more because it's 10 times 9 times 8, which is 720. Yes? So substantially more options because you are putting people for specific jobs. So you could go, if it was this, just a caveat, don't write this because you won't know why. But if you gave them different jobs, you could go 10P3. 10P3 is actually the same as the factorial of 10, like using the, fundamental accounting principle, 10, then 9, then 8. These are actually the exact same. So you would have, this is the number of blanks, and this is the number you start with. Same thing. So that's why I know what that answer is, because I'm going to 10 in the test. I'm going to pick 10, which is easy to add 0. All right, makes sense? 10P3 is all you could do, or you could go 10, 9, 8. That is the difference. But C's are different because they have this extra little factorial on the bottom. So watch this. This formula here says 10C, or NCR equals NC n minus R. So what does that mean? That means 10C3 should equal 10C 10 minus 3. That's what that's saying. So that's saying 10C3 should equal 10C7. That is not a C. Oh boy. That those should be the same. Right? That's what it's saying. It is correct. Let's show why though. We always ask why, we don't just memorize. So, the formula's NCR is n factorial over n minus r factorial. So if I go 10C3 equals 10C7, I'm going to plug both of them into that formula and see if I get left side equals right side, right? If this is true. So I'm going to go n factorial from the formula over n minus r, so 10 minus 3 factorial, which results in 10 factorial over 7 factorial, 3 factorial. True? We just did that one above. Okay, let's do it with the 7. So n factorial, 10 factorial, over n minus r, so 10 minus 3 factorial, 7 factorial. That is a lie. No, it's 10 minus 7. Yeah. 10 minus 7, which is 3. I got ahead of myself. Okay, so then this is, so it's n minus r, right? And then r. So we're going to get 10 factorial over 3 factorial, 7 factorial. Which ultimately is the same answer. Because 7 factorial, 3 factorial, 3 factorial, 7 factorial. Same thing. So it only works with C's because they have that extra r factorial on the bottom. Yeah? So there's also this weird brackety way you can show it as well. And it's on your formula sheet. It shows that NCR can be written like NCR or can be written in this vertical bracket style. Why? Because they said so. So instead of going 10C3 on a diploma, they could give the answer 10-3 or 10-7. Like that. That means 10C7, 10C3. Why they didn't do anything for a P? I don't know. Someone likes combinations better in math. I don't know. So if I gave you 20C14, what would that equal? 20C what? 6. What did you do? You subtracted that from that, yeah. That from that. Right? Only works with C's, don't do it with P's, it does not work. I'm going to prove it to you. So back here, 10C3 and 10C7 equaled, yes? Go 10P3 in your calculator. And then go 10P7. And P3 and 10P7. Very different, because what did I tell you about P's? I said they're bigger numbers, and I told you that you can represent this P using the fundamental counting principle. Yes? So this is the number of blanks. This is the number I start with. Yeah? So it'd be 3 blanks, and I start with 10, 9, 8. Yeah? Well, this would be the number of blanks, and this would be the number I start with. 10, 9, 8, 7, 6, 5, 4. Obviously bigger, right? Okay. Note when you have restrictions with combinations, that alters what you're choosing from. So let's look at example 2. To win the lot of 649, the reason why it's called 649 is you choose 6 numbers from the 49 first numbers, like natural numbers, 1 to 49. A person must correctly select 6 numbers between 1 to 49. Jasper selected the 6 numbers of the birthdays of his family, 3, 7, 9, 11, 20, 29. How many different selections of numbers could he have made? So when you get those numbers and they pop out the 6 numbers, they can come in any order as long as you have those 6 numbers, you actually win the lot of 649. Which you think, oh, that makes it, that's easy. Well, type it in. Type in 49C6. It's 13,983,816. Now, some people say, well, then if 13,983,816 people bought tickets, someone would win. Not true. If you pick a number, 6 numbers, someone else can pick those same 6 numbers. It's not like it gets locked down on the machine the moment those 6 numbers are picked. So that's why sometimes people, even if that many people bought a lotto, they don't win because someone didn't pick the 6 numbers. But someone else, a whole, like 100 other people picked 6 numbers that were the same. Okay? Now, think about it. It's hard enough to win the lotto in the first place, right? And there's weeks where it does not actually, people don't win. What if it was P? What if you had to get the 6 numbers in that order? It would be, get ready, 1 0 0 6 8 3 4 7 5 2 0. You too. 47. 10,068,347,520. Just a shot, you're probably not winning. It was inside the face after we're probably not. Okay?
That's what they always say at work.
Example 3. Let's look at 3. So now whenever we get questions, we're always going to have to decide whether they prints or comms from now till the end of January. Eternity, because you have both now. The athletic council decides to form a subcommittee of 7 council members. So they want a subcommittee, which is like a smaller committee of 7 council members, to look at how funds are raised. Whenever I get a committee, I always say to myself, okay, what I need to know first is I need to know of those 7 council members, if you're picked first or 7th, does life change? Is it different? If it does, then it's a P. If it doesn't, then it's a C, right? So that's where our head has to go every single time we get something like this. So let's keep reading. To look at how funds raised should be spent on sports activities in schools. There are a total of 15 council members. Of those 15 council members, 9 are males, 6 are females. The subcommittee must consist of exactly 3 females. Does it say anything about those people having jobs or anything specific that would make their life different? No, so it's a combination, right? Now, how do you guarantee getting puppies? Buying puppies. From puppies. True statement. How do you guarantee getting a car? Buying from the car. So you wouldn't go there and just like pull some SUVs out and be like, cool, I'm going to get a car. No, you wouldn't, because you could possibly get an SUV, right? Like if a parking lot had 100 vehicles to choose from that you could buy, and you chose a car from there, are you guaranteed to get a car? No, you would have to go to the minor amount, like 30 cars, and choose from them to guarantee getting a car, right? Puppies, you'd have to go to a puppy store and get puppies from it. I don't know if there's such a thing, but you know what I mean. Yeah. Or someone, if you want a cat, you wouldn't go to the zoo and be like, well, I mean like a cat. Like I don't mean like a tiger or a lion. Like I mean like a little house cat. You wouldn't go to the zoo and try and get a cat. So you would guarantee getting cats from cats, dogs from dogs, people from people, drivers from drivers, irons from irons. Whenever you're pulling an item from itself, it's a combination, because the order doesn't matter. Now some people will say, like we talk about hockey, we talk about defense and forwards, and they're like, well, the position, that order matters. But if you're choosing defense from defense, and you're choosing forwards from forwards, does it make any difference? No, because you're choosing, you just got rid of the problem, right? So, if I want to get exactly 3 females, a lot of people go, okay, well, I'll go 15C3, and then the leftovers, I'll choose the other 4. How do you guarantee getting females? Choose from the females. Like the puppies. That's it. Yeah, okay. So we need 3 females, because it says exactly 3. So I need 3 females, which means I need how many males? 4, because I need a 7-person subcommittee. Now do I need 3 and 4 to make 7, or do I need 3 or 4 to make the subcommittee of 7? And. So I need 3 and 4 equals 7. Right? Mathematically that is sound. That's the amount of people I need, right? But now I actually have to do the math to see how many different cases I can make, right? So how many females are there? 6, and I'm choosing females from females, so it's a C. Also, it's a subcommittee with no jobs. And means I do what? Multiply. And then males, 9C4 equals what? Just type it in. Even if you have a TI-83 or you have TI-84 or you have a TI-84CE or whatever, you can just type it in. You don't need brackets of any sort. It will lock those numbers together. because it takes whatever's numbers in front of the NCR and behind it and locks it to it, right? So you don't need the bracket for it. So you get 2,520. All right. Nice. Okay. Do I have to do this? All right. Paying attention? Table? All right. The class consists of 5 girls and 7 boys. A committee is to be formed consisting of 2 girls and 3 boys from the 5 girls and 7 boys. Determine the number of ways the teacher can choose the committee. Does it say anything about those people having specific jobs? No. So is it any different if they're picked the first boy or the second boy? No. So it's a C. So how do I choose this committee? I have 5 girls and I choose 2 and, so I multiply. 7 boys choose 3. $350. All right. B says Johnny, the principal's son, has to be on the committee. How do we guarantee getting Johnny? Okay, we have to get over the fact that Johnny's on the team because the principal's son. Suck it up. It's just the rule. Yeah.
Lower the spots of the guys on the 2.
You were going to have to lower the spots on the guys to 2. Yep. And what would be a way we could show that Johnny was on there, even though it's not going to affect it?
It's 6 total boys then because John's on.
Yep, so you guys are both connected in saying it's right. You'd have to go 6 total boys, choose 2, because you'd have to take one off here. And then 5 girls, choose 2. But what if I want to show that I chose Johnny? What do I choose Johnny from? How do I guarantee getting Johnny? I choose from John, right? I say, hey Johnny, you're making the team, but I have to pretend you didn't. Like, just get given it, but in this case you did. If you didn't show the 1C1, 1C1 is just 1, it's not going to change it. But it might make you feel better and make you remember to take 1 off of each of those things, which you guys did. Maybe Johnny was just a rock star to begin with, and that's why he had to be on it. Why are you guys getting all up in Johnny's grill?
It's like he has to be.
Yeah, because maybe he's a genius child.
And he'd be preferred to be.
What if he wasn't liked by many, but he would be really great on the committee, and therefore we had to get him on? Because if we made it be like voted in, he wouldn't. What about that? What about poor Johnny? Poor Johnny. I feel sorry for Johnny at this point. I feel like Johnny's being attacked. No, it's funny. I have given this example on my notes since 2012. My notes have changed a bit, but I know this one has been on there since 2012 when the curriculum opened for this. And no one has accosted Johnny so loudly outside out as you guys. They may have accosted him in their minds, but no one has verbally accosted poor Johnny.
Oh,
Yeah.
Everyone else.
Maybe, like it's narc. Okay. All right. Example 5. You guys don't answer any questions, but when you can narc on Johnny, you're all up in it. Poor Johnny. I now know where this class lies. In fairness, but also like attacking me. All right. Example 5. Can you look up here? It says, we're talking about cards. cards, unless I thought of like war is one where like you have to lay the cards the way they were given to you, like you know, like you have a stack of cards and you guys just flip it. Other than that, the moment you're dealt cards, what do? You put them in your hand. Everyone says look at them. I was looking. Some people like put them in their hand, yes? And then what do? Sort them to whatever the game is, right? Like if you know you might sort colors, or you can be a rebel like my youngest child, and they just are random everywhere. I was like, how do you play this game like this? Because I'd be like, oh, she has one blue left because she just played a blue from over there. No, she had like 4 blues because she just leaves them. Like it's actually quite a gaming way to go. Like you cannot predict her. So maybe she's smarter than I am, because I maybe shouldn't. I should just randomize my Uno cards. I learned from her. She's like, you don't know any of that. I was like, true, little kid. And she annihilates you. All right. So, you put them in your hand, and then you move them around. Yes? If you can move them around, did the order in which they were dealt to you matter? No, so they're a combination, right? Okay, so of a standard deck of cards, there's 52 cards. There's 4 suits, spades, clubs, diamonds, and hearts. Each suit has 13 cards. 2 suits are black, spades and clubs. 2 suits are red, diamonds and hearts. Face cards are considered to be jacks, queens, and kings. Okay. Remember how I said if you don't know where the factorial symbol is, I'm just going to walk away from you? I will not walk away from you if you don't know how many black cards are in a deck, because you can't be deck-sitted because you didn't play cards and someone else played a whole bunch of cards. Okay? So on a diploma, if they actually gave you a card game, they'd have to give you a card array. Often if they gave a card game, they just completely change it up. It's like 4 suits, blue, purple, green, and orange, and the number 1 to 10 or something. So that there's no benefit to play cards. Okay? So if you have to know where the factorial symbol is, I'm going to walk away. But if you don't know how many queens there are, I'll feel a little sad, but I'll just tell you. You won't know because I'll have a straight face, but in my head I'll be like, there's 4 suits, 4. But if you don't know that, you don't remember. 4 of everything. True. And face cards are the ones with faces. Faces are the jack, the queen, and the king. Okay? So there's 12. How many different 5-card poker hands are possible? So does it say anything specific as to what kind of cards we need? So this is total. So how many cards do we have to choose from? 52. 52. And we choose how many? 5. Type it in. So if you were ever wondering how many different card hands of like distinctly different cards you could put in your hand of 5, there is 2,598,960. It is. Okay. I'm going to let you guys try the next questions, keeping in mind that they're very much like if I need a girl, I pick a girl. If I need a boy, I pick a boy. If I need all diamonds, I have to choose from the diamonds. How many diamonds are there? 13. That's my hint. Now go. Try it out. Remembering that you always need to have how many cards? 5 cards. Let's see how you do. Some of them are going to be... So, if they want all diamonds, they go to the deck and they say, no thank you, everything else. They take the diamonds out, and they take the rest, and they give it to Johnny, who gets to go to the thing from the previous assignment. So it's fine. Okay, so there's 13. That's what I'm holding. In my hand, I have 13 diamonds. So I'm guaranteeing I'm getting them. And I'm going to choose 5 from there. Then I say, Johnny, give me back my cards, and I need to do a new question. Okay? You guys get the answers to those. I believe in you. All right. 14. That's not 14. 4 black cards and 1 red card. How do I guarantee getting the black cards? Go to my deck and take out all the black cards. Correct? How many are there? 26. Half the deck. Yeah. 26 C4 and means I multiply and red. 26 C1. So then I would set aside my black cards, grab all the 26 red cards, and choose one of them. Right? All right, 3 kings and 2 queens. So to guarantee getting kings, I take the deck and I take out the kings. How many kings are there? 4. And I choose 3. And I set those kings. I set the kings aside because I don't want them anymore. And I grab the queens. How many are there? 4. So not too bad. This one, I have 3 kings. The catch is, I need how many cards? 5. So I need 3 kings and 2 technically not kings, correct? Because I just get 5, but I can only have at maximum 3 kings, so the rest have to be just anything but kings. So, how many kings are there? Go to the deck and take out all the kings. How many kings? 4, C, 3, and means I multiply. 2 not kings. So I take those kings, the 4 kings, and I throw them away. And how many cards do I have left? 48. Now some people say 49. I remember in grade 12 I put 49. And then my teacher was like, well, you can't have 49 because then you would, but I only use 3 kings, and that's what I said to him. And he's like, yeah, but you can't have 4 kings. If you take 49, you have a chance of getting that king still, and then you could have 4 kings, and you'll not do, right? So that's why I decided that I would put not kings here. Help myself out. Sure. So there's 48 not kings, and I choose 2. Okay, 4 aces. Before I even start doing the question, I say I need 5 cards, right? So I need 4 aces and 1 not ace. So I have 4 aces, I choose all 4, and then I need not aces. So I go to the deck and I take out all the not aces. How many of those are there? 48. I know the answer to this one's 48. It's the only one I can do in my head. Okay. 5 cards of the same suit. Does it say what suit? No. So let's pretend I'm getting hearts. Okay? How do I guarantee getting hearts? Yeah, so I do 13, choose 5. So that would give me the hearts. Or I can't do and in between, because if I did and in between, I now have 10 cards, and I only want 5, right? Or I could do the diamonds, 13C5. Or I could do the spades, 13C5. Or I could do the clubs, 13C5. Or instead of showing this, I could go 13C5 times 4. Okay. Then flip. All right. These ones, and at least and at most, we're going to do on Monday. There's the at least in most cases. So what I'm going to give you is the questions out of here that don't involve those. So, okay, I just realized this. Number 6, do not get up in London's grill. London is my daughter, okay? She doesn't have to be on the committee because she's my daughter. Didn't leave that on here. Don't get up in her grill. I've never had this problem, so I'm just going to preface this. London is one of a group of 8 people from which a committee of 4 people must be chosen. The number of different committees possible if London must sit on the committee because she is the nicest human on the planet. And if you've never met London, you don't know. And I wish have you met London? Yeah. She is the kindest angel child. She will walk up to you and she will say, "You are awesome." She'll say, you know what, you're the best teacher. She says it to people all the time. She said to Miss Perry, did you know, her dog's Charlie, little boy, fluffy dog. She said to her, you are the best because Charlie is the best. And you raised her, and Charlie's amazing. She's been like that since a young lass.